Splendid afternoon to all. Welcome to Science Daily and Discovery Channel. We are here on Flora Vista to interview first-year medtech students from FEU and RMF to see if they are updated about immunoassays. May I ask you what is an immunoassay?
An immunoassay is a biochemical test that measures the presence or concentration of a substance, which is the analyte. It involves the binding of an antigen to antibody or vice versa, then determining with a detectable label, and finally, using a calibrator as a signal reference.
And what are the chemical properties used in immunoassays?
The chemical properties used in immunoassays are the following. First, if the analyte is an antigen, a specific antibody is required to bind to that antigen as a chemical reagent. If the analyte is an antibody, its cognate antigen is needed as a chemical reagent. Second, after the binding, detectable labels are used to observe if binding events occur. The chemicals which can be used as detectable labels are radioactive elements used in radioimmunoassays, enzymes, fluorescent, phosphorescent, and chemiluminescent dyes, latex and magnetic particles, dicrystallites, gold, silver, and selenium colloidal particles, metal chelates, coenzymes, electroactive groups, oligonucleotides, stable radicals, and others.
Finally, what are used to interpret immunoassay signals?
Calibrators are the physical property used to interpret the signal produced in an immunoassay. The calibrator mimics the characteristics of the sample medium.
Good afternoon.
Good
We're
afternoon.
from Science Daily on Discovery Channel.
Please come in. Have a seat.
Hi, Ms. Salvador. May I ask what are the types of immunoassays?
There are 4 types of immunoassays. One is competitive homogeneous immunoassay. The antigen in the unknown sample completes with labeled antigen to bind with the antibodies. The amount of unbound labeled antigen is then measured, which is directly proportional to the concentration of sample antigen. This is because the presence of more free labeled antigens means there was little no binding sites available on the antibodies, as they were all saturated with the sample antigen, which means it's high in concentration. The second one is competitive heterogeneous immunoassay. The antigen is the unknown sample competes with labeled antigen to bind with the antibodies. The amount of labeled antigen bound to the antibody site is then measured. In this method, the response will be inversely related to the concentration of antigen in the unknown. This is because the greater the response, the less antigen in the unknown was available to compete with the labeled antigen. And the third one is the one-slit non-competitive immunoassay. The unknown antigen in the sample binds with the labeled antibodies. The unbound labeled antibodies are washed away and the bound labeled is measured, which is directly proportional to the amount of the unknown antigen. The fourth one is the two-slit non-competitive immunoassays. The antigen in the unknown is bound to the antibody site. Then labeled antibody is bound to the antigen. The amount of labeled antibody on the site is the measured bound to the antigen. Finally, the two-slit non-competitive immunoassays. The antigen in the unknown is bound to the antibody site. The labeled antibody is bound to the antigen. The amount of labeled antibody on the site is then measured. It will be directly proportional to the concentration of the antigen, because labeled antibody will not bind if the antigen is not present in the unknown sample. This type is also known as sandwich assays, as the antigen is sandwiched between 2 antibodies.
Thank you, Ms. Salvador. You have answered my question very well. Thank you for your time.
You're welcome.
Good afternoon, I'm Carlo from Science Daily on Discovery Channel. I was hoping if I could have a moment with you. What are the principles why immunoassays are used?
An immunoassay is a specific type of biochemical test that measures the presence or concentration of a substance in solutions that frequently contain a complex mixture of substances. Immunoassays are quantitative and analytical methods. Antibodies specifically bind target analytes. Strength of binding determines sensitivity. Sensitivity and specificity determined by antibody assay conjugate pair. Flexible format provides for diverse applications.
Thank you. Have a nice day.
You're welcome.
Yes?
Good afternoon, I'm Carl from Science Daily on Discovery Channel. And I was wondering if I could have a moment of your time.
Sure, come in.
What's the theory of electrolytic solutions according to Skoog and according to Debbie and Howe?
In the paper on the theory of electrolytes, freezing point depression, and related phenomena by Debbie and Huckel, the symbol used for activity coefficient is Fa, while in Skoog, the difference is the symbol used is Yx, which represents activity coefficient. In the paper, there are a myriad of phenomena authors relate to that theory. Among the following are the several phenomena found in the paper. First, according to the dissociation theory by Arrhenius, there are abnormally colossal values of osmotic pressure, freezing point, etc. for solutions of electrolyte due to existence of free ions. Second, smaller values for freezing point are found in finite concentration due to presence of complete dissociation of electrolyte into ions, and according to Van Hoff's law, for complete dissociation, the osmotic coefficient must also be smaller. Third, the equilibrium between the associated and dissociated molecules depending on overall concentrations, pressure, temperature, and according to the mass action law of Gilbert and Wage, dependence on temperature and pressure of constant equilibrium can be determined thermodynamically. Fourth, electrical conductivity is determined by ions, and according to N. Bijerum, for strong electrolytes, no equilibrium at all is noticeable between associated and dissociated molecules. Electrons are completely dissociated into ions and have high concentrations, while in weak electrolytes, dissociated molecules reappear. Fifth, the electric energy of an ionic solution measures the thickness of the ion atmosphere. The thickness is inversely proportional to the square root of its concentration. The dipole theory states that for high field intensities, dielectrics show saturation phenomena similar to known magnetic saturation. And according to Berthelot's rule, the dependence of heat of dilution from initial concentration makes it plausible for the order of magnitude to experimentally determine the numerical coefficient. And finally, according to Kohlrausch, for low concentrations, the percentage deviation of molecular conductivity from its limiting value at infinite dilution is proportional to the square root of its concentration.
You have answered my question meticulously, and thank you for that detailed explanation. It's been nice meeting you. I hope we meet again in the future.